Were you aware of the fact that the average person has around 6,000 thoughts each and every day? Interesting, isn't it? Scientists estimate that we experience thousands of thoughts daily. Many are repetitive, and our brains tend to give more attention to the negative thoughts than it does for the positive ones. This is a phenomenon known as the negativity bias. The negativity bias says that just because you think something doesn't necessarily mean it's true. This is On the Couch with Dr. Ty. Welcome back, everyone. I'm Dr. Ty. Today we're going to be talking about the scientific method in psychology and how psychologists actually discover the truth. Today we're going to be looking at the most important concept in all of psychology, and surprisingly, one of the least understood. When most people think about psychology, they imagine a therapist, a clinician, couches, dreams, or maybe even mind reading. But psychology is much more than that. At its heart, psychology is a science. Psychologists don't simply rely on opinions or intuition. They don't accept claims because they feel right, but instead they use a structured process known as the scientific method to answer questions about human behavior, emotion, memory, personality, learning, and even mental health. The scientific method is what separates psychology from myth, superstition, and misfortune. It always allows for researchers to discover treatments for depression, identify risk factors for anxiety, improve education, understand relationships, and even predict certain human behaviors. Today, I hope we'll walk through the 5 major steps of the scientific method. We'll explain why each one matters, and we'll discuss how psychologists use this process every day to improve our understanding of the human mind. So let's dive in. What is the scientific method? Well, the scientific method is a systematic process that's used to investigate questions, solve problems, and test ideas through observation and evidence. Think of it kind of like your mom's recipe for your favorite cookie or cake. Just as you follow specific steps when baking this cake, scientists follow specific steps when conducting research. If one step is skipped, the results may not be trustworthy. One of the beautiful things about science is that it welcomes being challenged. Good scientists actually hope some try to prove what's wrong by finding what's going on in the repeated testing. Confidence in those findings becomes much stronger the more we try to prove things wrong or right. That is why the scientific knowledge continually grows. Let's look at step 1, observation and asking a question. Every scientific study begins with curiosity. Someone notices something interesting and asks, why does this happen? Let me give you an example. Why do some people develop anxiety while others exposed to the same stress don't feel any? Why do children learn languages more easily than adults? Why do people stay in unhealthy relationships? Why do eyewitnesses sometimes remember events incorrectly? These questions begin with careful observation. And psychologists observe patterns in behavior, emotions, relationships, learning, or mental illness before attempting to explain them. Albert Einstein said once that the important thing is not to stop questioning. And science begins with questions and not with answers. Imagine, if you will, noticing that a college student seems to perform worse on exams after sleeping only 4 hours. That's an observation. So now you would ask, does sleep deprivation actually reduce memory performance? You're right. Now you've begun the scientific process. Let's look at step 2. We call that forming a hypothesis. Once psychologists identify a question, they create something that's called a hypothesis. And a hypothesis is nothing other than an educated prediction about the researcher believes will happen. Key notes about this belief is it must be specific. It must also be measurable. And most importantly, it must be testable. So let's go back to the same example with sleep and exams for the college student. College students who sleep 8 hours before an exam will recall more information than students who sleep only 4 hours. Notice that this statement can actually be tested. A poor hypothesis or educated guess would be sleep is magical. See, there's no specific scientific way to measure magical. Good science requires measurable ideas. Psychologists also identify two important variables, the independent and the dependent variable. The independent variable is what the researcher changes, and the dependent variable is what the researcher measures. So in our example with the college students and sleep, the independent variable would be hours of sleep, correct. Then our dependent variable would be what? Memory test scores, you're correct. This allows psychologists to determine whether changes in sleep actually influence memory, which moves us on to step 3, which is actually testing through the research. This is usually what we consider the exciting part. The hypothesis is tested. Psychologists conduct experiments or other forms of research to gather more evidence, and depending upon the question, researchers may sometimes use experiments. Sometimes they use surveys, observations, interviews, case studies, psychological testing, brain imaging, longitudinal studies. All these are tools. Experiments are considered the strongest method for determining cause and effect. Imagine, if you will, recruiting 100 college students. Half of them sleep 8 hours, half sleep only 4 hours. The following morning, everyone takes the same memory tests. Everything else remains the same. Same room, same instructions, same tests. Only one thing changes, and that's the duration of sleep. So, by controlling everything else, psychologists can determine whether sleep actually caused differences in memory. This process reduces bias and increases confidence in the findings of our research. So sometimes when we're finding research, we have to concern ourselves with samples. And samples are those things that help us be able to determine who's going to be in the experiment or the research. And the size of the sample is also important. So, why is sample size important? Why does it matter? Well, suppose only 2 people participated in our research that we spoke of earlier with the sleep and the test. One performs well and one performs poorly. Would that tell us a lot, or would it tell us very little? Tell us very little. Larger samples provide more reliable results because they better represent the population that we're testing. Researchers also try to make their samples diverse. We try to mix the ages with the different backgrounds, different cultures. Sometimes we even try to sprinkle different genders in our sample. The more representative the sample, the more confidently findings can be generalized. So, step 4 brings us to analyzing the data. Once all the data are collected, psychologists analyze it using statistics. Many people become nervous when they hear that word statistics. I know a lot of my learners do. But statistics simply help answer one important question. Did this result happen by chance? Suppose the sleep group scores 92% and the sleep deprived group scores 68%. That's a notable difference, isn't it? But statistics determine whether the difference is large enough to conclude that sleep truly affects memory rather than just random luck. Researchers often examine averages, percentages, correlations, and significant testing. Statistics transform raw numbers into meaningful conclusions and data. Without stats or statistics, psychology would just be simply a shot in the dark or guessing. One of the key elements I like people to remember when we're talking about hypothesis and research is correlation is not necessarily causation. This is one of psychology's most famous principles. And what that kind of means in a nutshell is just because two things occur together does not mean one caused the other. Let's break that down a little bit further. Ice cream sales increase during summer. Drowning deaths also increase during summer. Does eating ice cream cause drowning? Of course not. The hidden factor is the warmer weather. Similarly, people who sleep less often report higher stress. Does poor sleep create stress? Does stress reduce sleep? Or do both influence each other? Science kind of helps us untangle these complicated relationships. So, brings us to step 5. And this is where we draw conclusions and we start to share our results. Once the data have been analyzed, psychology determines whether the evidence actually supports our educated guess or our hypothesis. At times it does, and at times it doesn't. And that's perfectly all right. Science values truth, not being right. If evidence contradicts the hypothesis, then researchers learn something valuable. Negative findings are just as important as positive ones. After reaching conclusions, researchers publish their findings in scientific journals. Before publication, other experts also review the study. This is called a peer review. Peer review acts as quality control before we share our results. And this is when other psychologists actually examine the methods, the statistics, the conclusions, as well as the limitations. If flaws are found, researchers may revise the study or conduct additional research. Science is always improving itself. So, what's the secret ingredient? Replication. One study rarely changes psychology, but replication does. And replication means other researchers repeat the study to see whether they obtain the same results. If multiple independent researchers continue finding the same answer, confidence starts to increase. This is why psychology values evidence over opinion, and good science can be repeated. So, has psychology always gotten it right? Absolutely not. Which brings us to ethics in psychological research. Early research sometimes harmed participants. Back in the day, you could do just about anything you wanted to do to your test samples. But today, psychologists follow strict ethical guidelines. Participants must provide informed consent. Confidentiality must be protected. Participants may withdraw at any time. Researchers must minimize harm. These safeguards protect both science and the people that are participating. Many groundbreaking discoveries came from the following of these 5 steps. Researchers discovered that cognitive behavioral therapy, aka CBT, effectively treats many anxiety disorders. Scientists demonstrated that regular exercise also improves mood. Developmental psychologists identified critical milestones in child development. Researchers working with memory discovered that eyewitness testimony is often less reliable than people believe. None of these discoveries happened overnight. They resulted from many years of careful observation, hypothesis testing, statistical analysis, replication, and peer review. So, why does any of this matter to everyday life? Well, you don't have to be a psychologist to use the scientific method. Think about improving your sleep. Instead of trying 5 different changes at once, change only one variable. Go to bed 30 minutes earlier tonight. Observe what happens. Collect the information and draw your own conclusion. The same approach works for studying, exercising, managing stress, and even improving relationships. The scientific method teaches us to think critically rather than emotionally. In today's world of social media, misinformation spreads like wildfire. Understanding the scientific method helps you to ask better questions. Where did this information come from? Was it studied? Can it be replicated? Is there any evidence supporting this? Those questions protect us from believing myths. So, what are some of the common psychology myths? Well, I like to say that we can bust the myths by having knowledge, but there still are myths that just kind of get away from us. One myth would be, why only use 10% of our brains? Or do we only use 10% of our brains? That's false. Brain imaging shows that we use every part of our brain, and every part of our brain has a function. Here's another fun one that I've heard before. Do opposites always attract? Well, research generally finds that similarity predicts relationship satisfaction more than differences. Try that one on for size. How about, does our memory work like a video camera? Well, actually, memory is reconstructive. Each recall can subtly alter what we remember. Science corrected all of these misconceptions. In conclusion, the scientific method is much more than a classroom concept. It is a foundation upon which psychology is built. Every therapy, every diagnosis, every treatment recommendation, every research article, every major discovery, they all begin with the same 5 steps. First, observe and ask a question. Second, develop a testable hypothesis. Third, conduct research and collect evidence. Fourth, you're going to analyze and use the data using statistics. And then finally, we draw a conclusion. We share the results, and we allow other scientists to replicate the findings. Psychology continues to evolve because science never stops asking questions. And perhaps that's the greatest lesson of them all. Curiosity has constantly changed the world. So, I want you to remember, understanding the mind begins with understanding the science behind it. Stay safe and stay smart. This is On the Couch with Dr. Ty.